I don't know if you're interested in meteorology, but I used to work as a meteorologist, and now I'm responsible for meteorological database from Wawrzyniak Station in the Arctic. And there, meteorologists do the observations of different types of clouds. Every day when you just go out and try to see the sky, you can see different types of clouds, and hopefully after this lesson you'll be able to recognize them and name them. Let me just switch to my presentation. When we talk about clouds, first thing to do is considering water cycle. Water cycle is the constant movement of water in the nature, and the water moves on Earth permanently. So it means there's no beginning or no end of the water cycle. But there are different places where you can find water. So let's start, for example, with clouds. Then we have precipitation, so rain or snow, or drizzle, or different types of precipitation that fall to the ground or to the water on surface of the Earth. So we can have snowmelt runoff or surface runoff. Water also infiltrates into the groundwater. So in the ground it moves. We can have lakes, streams, or oceans and seas. And then from this open water, there is this process called evaporation. That means that water changes its state from liquid to water vapor. Other type of evaporation is evapotranspiration. That's changing of the state of water into vapor from the plants. Different plants, from forests, from meadows. There is also changing water into vapor. Then other process is called condensation. Condensation is when water is changed to solid or liquid. So condensation is the change in the state of water vapor to liquid water when it has contact with liquid or solid surface or cloud condensation nuclei. What are these? Cloud condensation nuclei are different particles that are in the air, for example, dust, or just it can be aerosols of different types. So when we have this kind of nuclei, the water contacts with the surface and appears as liquid. So then you can see clouds. Other process is evaporation, as it was mentioned before. So change of the liquid to vapor state. All those clouds are made up of tiny water droplets or ice crystals. It depends on the temperature, of course. When it's below zero, then you get ice crystals. And those droplets are so small, they can float in the air. That means that they can move with masses of air. If those droplets become large enough, you will be able to see them as clouds or fog. They can even become larger and larger, and then they can fall as rain or snow, depending, of course, on the temperature, as it was mentioned. So here we have the picture taken in New Zealand. There's some lake, some forest, and we can see the process of evaporation and evapotranspiration, so changing from liquid to vapor state. High above, where the temperature is below zero or below the dew point, you can see the clouds. The dew point is the temperature to which a humid air must be cooled and at which air becomes saturated in equilibrium with water. So we can see condensation into liquid or solid state of water. The main topic is identifying clouds. That was like main topic of the previous day of meteorologists. That was on the 23rd of March. That was the day when we were celebrating Meteorological Day. The main organization in the world that that is that governs all the measurements made by meteorologists around the world is WMO, World Meteorological Organization. That's an agency of the United Nations whose mandate covers weather, climate, and all water resources. It was established on the 23rd of March, 1950, and it was established for standardization of all meteorological and all related observations, because they just have to be done the same way. Few facts about WMO. WMO has 191 member countries and territories. There are 11,000 land stations and 3,000 aircraft, together with 4,000 ships and 2,500 buoys at sea, from which we get the meteorological data. And those data are collected and sent to WMO centers, where maps and charts are created, and where the weather forecast is prepared. To get the proper forecast, we need many points of observation. That's why we have standardized observations around the world. Today we will learn how to identify different cloud types. For that purpose, I will use a flowchart that was prepared for the International Cloud Atlas. It was published in March this year by WMO. So let's start with it. Yeah, first we have to name different families of clouds. There are 4 different families. The first one is called low-level clouds. That means that in this family there are clouds that are from the ground surface up to 2,000 meters. The other ones are mid-level clouds. That means from 2,000 meters above the ground up to 6,000 meters. And above there are high-level clouds above 6,000 meters, so 6 kilometers above the surface of the Earth. And the fourth family is called vertical clouds, and in this family there's only Cumulonimbus, that's sometimes classified as low level, but it goes through all levels. It's really high cloud. Most names of clouds contain Latin prefixes and suffixes, which when combined give an indication of the cloud's character. These characters were described by some meteorologist Luke Howard in the beginning of 19th century. And those names, those Latin names, include stratus. Strato, it means flat, layered, and smooth. Cumulus, it's heaped or puffy. Cirrus is feathers, wispy. Nimbus, that means rain-bearing. Alto, although in Latin it means high, alto clouds are mid-level clouds. The cloud that is the easiest to recognize is Cumulonimbus. And just to know if we have Cumulonimbus on the sky, you just have to ask yourself a question. Do you see the lightning or can you hear the thunder? If the answer is yes, for sure there is Cumulonimbus. That's a huge cloud tower which sometimes can have anvil shape. As you can see, the upper parts look like anvil. And there are possible thunderstorms. If you hear the thunder or see the lightning, there is Cumulonimbus. And that's the easiest cloud to recognize. And actually the most dangerous because of thunderstorms. Let's go back to the question. If you cannot hear or see the lightning or hear the thunder, other question is, are individual bogging heaps or domes clearly visible? If the question is yes, ask yourself another question. Are there fuzzy outlines at the upper third part of the cloud? If the answer is yes, for sure there is Cumulonimbus on the sky. If the answer is no, you can guess there is cumulus. Cumulus are isolated puffy clouds with sharp outlines. Again, you didn't hear any thunder, you didn't see any lightning. So the question was, are individual bulging heaps or domes visible? If the answer is no, another question is there a uniform, continuous or broken layer that has no rolls or elements? If the answer is yes, just ask yourself another question. Does the sun or moon appear as a bright patch? If there is a ring around the sun or during the night around moon, for sure there is Cirrostratus. So you have this effect of halo, which is a ring around the sun or moon. And Cirrostratus looks like transparent, milky or fibrous veil that casts shadows. So you won't see your shadow on the ground. Another question, is there an elevated gray or bluish to dark gray sheet-like layer? So, if yes, there is altostratus. Yeah, no shadow. Another question, is there a dense, if the answer for the previous one was no, another question you have to ask yourself, is there a dense, extensive lower layer with diffuse or wet appearance? If there is rain or drizzle, you can guess it's nimbostratus. Yeah, nimbostratus is always rain, that's dark clouds with or bright snow. And usually you will get continuous rain, snow, or ice pellets. If the answer was, so the previous question was no, there is stratus cloud, which is low-level cloud, usually just a few hundred meters, like 300 or so above the ground level. And from stratus, you can expect drizzle or snow grains. If sun or moon is visible, its outline is clear. It can occur in fragments. Let's go back to the previous question. There was no uniform, continuous, or broken layer. So the question is, are there white wispy fibers or filaments? If the answer is yes, on the sky you can see cirrus, which are high-level clouds. Cirrus are made of solid water state, so mainly ice particles. And cirrus has form of hooks, feathers, bands, or patches with silky shimmer. If the answer for previous question was no, there were no fibers, or yeah, you just see this kind of clouds on the sky, also high above. So you get cirrocumulus clouds when your answer for the question is each element smaller than one finger. So just stretch your arm to the sky like that. It can be a thumb up. And if the clouds are smaller than your finger, you can see those small puffs, you get cirrocumulus. If each rounded element is of size between 1 and 3 fingers, you get altocumulus, which is a middle layer of puffy clouds. If there are bigger clouds of size 5 and 10 degrees, full hand, they look gray or whitish, like fields, rolls, or bundles with rounded edges at low level. You get stratocumulus. So these were the main types of clouds. Now let's go to low-level clouds of different genera. So when you get, you are sure that there are low-level clouds. So that meant between ground level or 2,000 meters. You just ask yourself a question. Is cumulonimbus present? If the answer is yes, Another question, is it clearly fibrous? Does it have an anvil or plum shape? If yes, you get Cumulonimbus capillatus. If there is no plum or anvil shape, it's Cumulonimbus calvus. So upper parts are lacking sharp outlines. And you can expect different forms of showers. So it means the precipitation with duration is few minutes or let's say 15-20 minutes from those huge clouds. If the answer to your question was no, there was no cumulonimbus present, ask yourself another question. Is it formed by spreading out of cumulus? If the answer was yes, so you will get stratocumulus cumulogenitus. That means flattened due to a stable layer or during the afternoon. So clouds that are made of cumulonimbus, they come from cumulonimbus, but they don't have this tower huge shape. Another question, are cumulus or stratocumulus on different levels? If yes, cumulus and stratocumulus based at different levels, you get those clouds as you can see on this chart. If the answer is no, ask yourself another question. Is the vertical extent moderate or great? If yes, you get Cumulus mediocris or Cumulus congestus. So they look like cauliflowers. If the answer to your question about the vertical extent was no, you can name those clouds, asking yourself another question: which of the four remaining clouds predominates? When you have stratus fractus, that will mean, or cumulus fractus, it's just before or during or after precipitation. If there's stratus nebulosus or fractus, smooth, uniform layer or in ragged shreds when dissipating. Another cloud, cumulus humilis, it's a cloud of good weather. So when you can see this kind of clouds, you can expect that the day is really nice, and those clouds have very little vertical extent. If there's stratocumulus, if the stratocumulus not formed by the spreading out of cumulus, that's another type of stratocumulus, rounded shapes with shading. As you can see in the braces, there are numbers for each of these clouds, and these numbers are used by meteorologists to describe each type of the cloud. So CL means clouds low, and with specific number, they appeared on previous, as you can see, on previous names of the clouds. The code that is prepared, so code in numbers, that is prepared by meteorologists and sent to WMO, so to the World Organization, World Database. No one writes stratus fractus, no one writes stratus nebulosus. Those names are sent by numbers. So when you will see the code, meteorological code called synop, maybe you can read which kind of clouds were coded. So for example, cumulus humilis, good weather, low clouds number 1. And most meteorologists know all the numbers, or they use charts like this one that I'm presenting today. When you have middle-level clouds, you just ask yourself a question. You start here. Is altocumulus present? If it's not present, just ask yourself a question. Is the greater part of altostratus thin? Sorry, but there's a phone behind me. Happen, I'm at work. Sorry about that. Is the greater part of altostratus thin? So tiny layer of altostratus. It means it will be translucid so we can see where is the sun on the sky. Although it's not like, really bright, you can see the position of the sun or the moon. So this tiny layer of altostratus is called translucidus, and the number for that is cloud medium level number 1. If you ask yourself a question, is altocumulus present? And it is present, ask yourself a question, is the sky chaotic? If the answer is no, just ask yourself, are there turrets or tufts? So are there any towers? So clouds that are taller than wider. If yes, you will get altocumulus, castellanus, or flocus. Let's go back to the question. Is the greater part of altostratus thin? If the answer was no, ask yourself another question. Is the cloud base diffuse and lowering? If it lowers, that means that you have altostratus opacus. So you won't see the position of the sun on the sky. That's the number 2 for medium level clouds. If the answer was no, when there is continuous precipitation, for sure there is nimbus stratus. Yeah. Another question. There were no turrets or tufts, as you maybe remember. Another question is, are altostratus or nimbus stratus present? If yes, you will get altocumulus and altostratus, or altocumulus and nimbus stratus. The number is medium clouds number 7. Are altocumulus formed by spreading out of cumulus or cumulonimbus? If the answer is yes, so there was a storm before, you saw the you heard thunders, you saw lightning, but they disappeared. They changed to altocumulus cumulogenitus or cumulogenitis. That means flattening of cloud tops occurring when cloud grows into a stable layer. If the answer was no, it's altocumulus invading the sky. If it does invade the sky, you get altocumulus invading the sky, which is number 5 of medium level clouds. If the answer is no, you just ask yourself a question. Is altocumulus continually changing? If yes, you get altocumulus lenticularis. That means smooth lenticular elements at the one or more levels. If not, altocumulus wasn't changing, ask yourself a question. Are altocumulus clouds are at 2 or more levels? If the answer is yes, there is altocumulus duplicatus, which means many levels. It can be 2 or more. If the answer is no, are altocumulus clouds semi-transparent? So it means there are breaks between clouds. Then you get altocumulus translucidus if there are if these clouds are semi-transparent. There are patches or sheets at a single level. If not, altocumulus opacus, which is thick patches or sheets of clouds. So now we know all the low level and middle level clouds. So it's time to switch to high level clouds. The question is cirrocumulus predominant? So you remember the cloud that was smaller than your one finger in front of you. So you were just pointing your finger into the sky on straight arm, and those clouds were smaller than your finger. So the question is cirrocumulus predominant? If yes, you can name this cloud. It's cirrocumulus. which number is number 9 of high clouds. If not, another question is Cirrostratus present? If not, another question is, has Cirrus originated from Cumulonimbus? If yes, you get Cirrus pissatus, Cumulonimbogenitis. So that comes from the huge cloud called Cumulonimbus. Once it was moved and disappeared. It's not a huge tower as it was before. It's changed. There was precipitation, there was thunders, lightning. Then they move and you just see on the sky Cirrus pissatus that came from Cumulonimbus. If not, the question is, Cirrus is in dense patches predominating? If yes, you get Cirrus pissatus, that can look like dense patches or entangled sheaths. If not, Cirrus fibratus. They look like hooks or strands or filaments. There was no predominant cirrocumulus. Cirrostratus is present. So another question, is Cirrostratus covering the whole sky? So you cannot see blue sky. Cirrostratus is covering whole sky. Then you get Cirrostratus nebulosus. And there is halo phenomena usually on the sky. If the answer was no, is Cirrostratus veil constant or decreasing? If yes, you get Cirrostratus, which is edge of the veil, maybe clear cut or frayed. If not, the question is Cirrostratus veil more than 45 degrees in the sky? If yes, Cirrostratus higher than 45 degrees, the number is CH, so high cloud number 6. If the answer was no, is Cirrostratus smaller than 45 degrees? The number is CH5 of the Cirrostratus. And these were all the names of the clouds, all genera. So hopefully after this lesson, you will know how to use WMO Cloud Atlas. So that's something that you can find on this website here. If you type wmocloudatlas.org, you can go to clouds. There are different definitions, different descriptions of clouds. You can read about orographic influences on clouds. Let's click on that. So here is the information. If the airflow is crossing a hill or mountain ridge, you get orographic clouds that may occur below or above the top of those obstacles, such as mountains. I would like to show you some examples of orographic clouds. So as you can see, there is this obstacle. So the air moves towards us, and and the air mass is pushed up by this obstacle. So the air mass cools down. That means that the dew point appears, and above this dew point, so below the temperature, there are clouds that are produced above mountains. So everything that I presented today can be found on the website of WMO. You just have to find all the types of clouds. Here are different classifications. For sure you have this in your handbooks. But just remember, you have all those names, but those clouds are beautiful. And the task for you for the next week, and that's something that your teachers have to check, is each of you should take at least 3 pictures of clouds, of different clouds. Then share them with your friends, you should show them and name all those clouds. Using, of course, this cloud atlas. There is also different cloud atlases on the internet. For example, cloudsonline.com, where you also will find all different names of clouds. So once you'll take picture of clouds that look like that, yeah, you can be sure that Cirrus and Cumulus, which are hooks, but just call them Cirrus. And hopefully this will be useful for you. On this atlas that was published by WMO, you can see more than 1,000 or 3,000, something between 1 and 3,000. I don't remember the exact number, but many different types of clouds and many pictures. So, for example, if you check Cumulus, yeah, you can find a picture and compare it with pictures taken by you. So as for now, I would like to thank you for your attention. If you have any questions, just ask them on the chat.